Does that make sense? Does that seem reasonable? That kind of pushing things back, it actually has worked out well. As long as we don't have any more crazy days before break, I think we should be in good shape. Okay.
How about we don't do any more work until winter break?
Yeah, that's not going to happen. Because see, the problem is, and this is what I was trying to just say, is that if we don't do anything else before winter break, then we're going to have to pick this stuff back up after winter break.
Yeah, that's even worse. I did that 1 year.
You're with me? So that's really what I want to do is get this done so that January 8th or 12th or whenever we actually start again, I can't remember, then we'll move on to something different. Okay? So the other thing that I do want to let you know of, because it's going to affect your schedule and your plans and all of that sort of thing, is that I am going to do a problem set, which is a new thing that we've never done before. And I put that here. So you've got homework, this chapter 235, You may or may not have done that already. And if you did, awesome, good for you, but I'm not going to stamp it today. I will stamp this one on Friday. I'll stamp this one tomorrow. Okay, this one here. So we've done one. I'm going to stamp this one. On Friday, that's tomorrow, I'm going to hand out a problem set to you. Let me tell you what a problem set is because we've never done one before. A problem set is going to be, I'm thinking like 4 questions, okay? 4 problems. I will not give you the answers to them, okay? You will turn them in for accuracy. Not like that chunky, but things, the reason that I do a problem set is maybe threefold. One is to help you review, to see how you're doing, to build your confidence up. Number 2 is to get you to work together. It's not just called a problem set, it's called a partner problem set because I want you to work with other people. I'm not going to assign like you and you have to work together. I'm not going to do that. But I do want you to feel free to collaborate on that. And then the third thing is that the problems that I write on a problem set are harder than the problems on a test. But you can use your notes and you can use each other and right? Because I don't want to give you really, really hard problems on a test because I don't think that's fair. But I do want you to be exposed to them. And I want you to gain confidence by doing them. Does that make sense? Okay. So I'm going to hand that out on Friday and that will be due on the 21st on that review day that we have. So that we can talk through them. You can find out how you did. Does that make sense? So that you can actually get feedback. Tomorrow. I'm going to give it to you tomorrow. Okay. Well, I'll post it up on Canvas and then you can get it there. Sound good? And then it will be due on Thursday. So you'll have almost a week to work on it. Okay. Questions about any of that stuff? All right, so last time that most of you were here, I was not here because I had the joy of sitting in meetings. Yay, team. And you worked on some friction problems that may or may not have gone great. And then you worked on that friction lab that may or may not have gone great. So really what I want to do today is kind of sweep up everything and put everything in nice, neat boxes so that we're feeling good about it. Does that make sense? So I kind of want to split the day between those 2 things. Is that okay?
I don't know. I was gonna ask like this thing. So we took the notes from a video. It's stressing me out because I don't even know what I wrote, and now I just it's all clutter.
Yep. So we're gonna go through it again.
Can we restart it? Get a new sheet?
Yep.
Yeah.
I don't have more paper, but you have lots of paper, and so you can just write it down on paper. I don't think I have any more copies. If I did, well, maybe I do. I don't know. I'll look and see if I find.
would need one.
I call it.
What's that?
I call first one.
Wait, I don't have one at all.
Janelle calls first one.
Fine. I get second. I get third.
But I'm not going to take time to look for it right now. So life is hard. Okay. So my plan is to go through those problems. Okay. And then let's see. 24. So
Would you recommend using different colors for the thing?
I love colors, right?
Okay.
I'm going to say at 10 after, somebody who's got you have a good eye on the clock, don't you, Dylan? Yeah, at 10 after, just give me like a hey, and we'll make sure that we're ready to move on or moving towards the next thing. Okay? You can.
10 after 1.
Yes, 10 after the hour. Yeah.
Oh.
Have you never heard that term before?
I've heard it a lot. I've never.
You just knew what it meant. Does that make sense now?
I heard it way too often.
So, and then you can say like a quarter after. Is that okay?
Quarter after,
Yeah. So it's just like 10 after.
Yeah, that makes sense, actually.
Hey, learning new things today.
I never think about it. Quarter after someone says it, you just go, okay, quarter after, you know, whatever. 10 after, I think, like, what do you mean 10
I
after?
was just saying, I thought it was weird to think about.
But now I understand. So it's like-
All right. So this is the purple problems that you have or don't have, but I'll find another sheet and just write on paper for now. Is that okay? And you can just write 416, and I'll put this up on YouTube and all that good stuff so you can have access to it as well.
I have a question.
Yes.
Would this sheet be part of like a homework packet?
No, this was the whole purpose of this. I was trying to give some notes while I was not here. I recorded the videos kind of fast.
Oh, you have videos?
They're video, yep, they're up online. Yeah. So you can look, but we're gonna do them right now too. And I'm recording it again. Like double video time for Miss Carbling with this problem. All right, here we go, team. Here we go. Shh, stay with me so that we can get focused. So the situation was we have our 10-kilogram mystery box again at rest on a horizontal floor. But the horizontal floor is not smooth anymore. It's rough. It's got some sort of bumps on it, okay? It says that the coefficient of static friction is 0.4, and the coefficient of kinetic friction is 0.3. How are we doing? Are we okay with that information? That means that if I'm pushing on the box and it's not moving, mu is going to be 0.4. As soon as that thing gets moving, now the coefficient of friction becomes less. It's easier to push it once it's moving, okay? Just like it was when you did the little lab, right? You were pulling, it spiked, and then it went down, okay? This is the high part, this is the low part. This question is interesting because it's got 5 parts. It says determine the force of friction acting if the box had a horizontal force is applied of any of these magnitudes. It's a lot of magnitudes. That's like a lot of problem, right? So if you look at that at first, you're going, holy bananas, Carbling, that's a lot of problem. But it's really not if you break it down. So ladies, I'm going through this, so I want you to listen, since we're doing this for the second time, right? If you said it was hard, let's listen, because the stuff I'm saying, even though I'm not writing stuff down, still matters, right? Like I'm not just talking at myself. Okay. All right. So let's get ourselves a box. A mystery box that has a mass of 10 kilograms. It's sitting on a floor. And help me out, guys. What kind of forces are acting? Raise your hand if you can tell me one of the forces acting on the box. Or just say it out loud. Go. The first, which would be the force of the earth. Yeah, maybe.
I remember the first time you wrote F Earth, and I thought it was Firth, and I'm like, where is she pulling this from?
It's a new language. All right. Life is good? Okay. Sweet. All right. Next force. What else is acting on the box? The normal force, the floor. And which way is that one pushing or pulling? Up, right? Up's not a frictional force. Sorry about that. It's a normal force. Okay. So far, so good? Everybody happy? All right. So that was an easy problem. We did that one a while ago. Now we're saying that there's going to be an applied force exerted of different magnitudes. The first one's 0. Let's not worry about that for right now. Let's just draw this picture. Okay. Do you want to say something, May? Why?
I don't know, it's so much writing.
Okay, so I was reading it through. I was talking it through. I'm not trying to say this in a mean way, but
like all the words in it, just there's so much.
right. And what I'm trying to say is that I'm trying to help you, and I talked it through a minute ago while you guys were having a conversation. So if you stay with me, I'll get you there.
I said to her that I was confused. And that it was
Okay. Well, let's move on now. Where are you stuck right now, honey? Are you sure? Okay. I want to get you there. Okay. That's why we're doing this. What other forces are acting, guys? Friction, probably, since we're supposed to find it, right? Yeah, so, I mean, no, so I don't mean that in a bad way. Like, absolutely it's acting because it says, what is the force of friction? So it's going to go this way, let's say. It's kind of an arbitrary choice, but I'm going to say that it's this way, it's horizontal. It's always going to be what to the floor, or always going to be what to the surface? Always going to be parallel, yeah. It's the force of the floor on the box that's parallel. I'm just going to write myself a little friendly reminder that the normal force is always perpendicular. Did my door just close?
Yeah.
Okay. And the force of friction is always parallel to the surface. Okay, those are just some friendly reminders to not forget. Okay. Any other forces acting? There's an applied force, right? Which way is the applied force going to go based on what I've drawn so far? Opposite of friction, right? Friction also always opposes the motion. It's always going to try and slow something down, right? So this is the force of the person on the box. Okay. How are we doing? We okay? All right. Do we know any numbers that we should take note of or pay attention to? We know the mass. The mass is 10, right? We know the coefficients of friction. Yep, those are up there, 0.4 and 0.3. If we know the mass of the box, can we figure out the gravitational force? Have we done this before? Like a couple of times? Yeah, we have. And so we found out that Fg, do you remember what it was? 10 kilograms times 9.81 meters per second squared. I'm just kind of going through this to make sure we're okay. It's going to be what, 98.1 newtons? I'm just going to remind myself that it's down. We can also remind ourselves, if we look at the net force in the y direction and the up and down direction, is the block accelerating in the y direction?
No, it is not.
It is not. It is not. So I'm just gonna, I'm writing this all out just to be super clear here. F net in the y direction, I'm gonna write a little y down there to remind myself I'm just doing the y stuff, is the normal force, whoa, plus the gravitational force. Those are gonna add up to 0 because you just told me it wasn't accelerating. Which means that the normal force has to equal the opposite of the gravitational force. So it's gonna be 98, whoops, sorry about that, 98.1 newtons up. How are we doing? Are we okay so far? In part A, it says that the force exerted is 0. If the force exerted is 0, what do you think the frictional force is going to be?
0.
0, right? Because is the box going to go anywhere? No. Doesn't ever make sense that the force of friction is going to be bigger than that. So I think for part A, I'm just going to kind of scroll down here and say, for A, the frictional force is going to be 0. That was easy. Part B, now it says that the applied force is 10 newtons. How are we going to do that? What are we going to do?
There was an equation
There was an equation?
that you gave us. Remember?
I don't remember, but talk to me about it.
Look for it. Which one are we looking for? F of
Force of friction equals.
the static or
Yeah,
kinetic?
they would use
Okay. The force. So what's gonna apply first, the static or the kinetic? Static, because that's the thing that really matters, right? That's the kind of like that threshold that we have to overcome. So force of friction, static. Did I write it kind of like that maybe? And it was the force of friction is less than or equal to mu Fn. Does that sound familiar to you? Yeah, should I maybe even write that up here? Force of friction static is going to be less than or equal to the static mu times Fn. What was that?
No, I was just saying, what if we got that?
Oh, yeah, good show. This less than or equal to means that it's going to get bigger and bigger and bigger and bigger and bigger until that moment, right? Maybe we should figure out what that threshold is. What is the biggest that the static friction can be? I want to find the highest that FF sub S can be. Because remember, if you think about the graph, it goes up, 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 boom. Right? I want to know this point right there. Because until then, it doesn't matter how much I'm pulling, it's not going to go anywhere. Can I find that value? I can. How do I do that?
So for mu, you put in
24.
Point.
oh whoa, that means
Why 98.1? Because that's the normal force. Indeed. You got it.
so what's the 10 newtons? Oh,
That's going to be the applied force.
Ah,
So pull your calculators out, ladies and gentlemen. 0.4 times 98.1. What was it?
Yeah, sure.
So that is the maximum static friction. So if I push with 10 newtons of force, am I going to get the mystery box to move? No. If I push with 20 newtons of force, am I going to get the mystery box to move? If I push with 30 newtons of force, am I going to get the mystery box to move? No. How much force do I need to apply? 39 point, like a little bit more than 39.24, right? That's going to overcome this, and then I'm going to be like going fine, right? Does that make sense? Okay, so now let's take that one step further. I'm going to scroll back up for just a second here. So at 10 newtons of force, if I apply 10 newtons of force, you said it's not going to move. What's the force of friction going to be then? If I apply 10 newtons of force, is the box going to accelerate?
No.
So that means that if I add this one plus this one, what does it have to be? 0. So if I apply 10 newtons, what's this one got to be? 10 newtons, yeah? Is that making sense? Let me write that down. Let me write that little F net equation down. Gerald, it's nice to see you. FA plus negative FF. This is our little key to the world here. Okay. If this is 10, this has got to be negative 10, or 10 in the other direction to add up to 0 because it's not going anywhere yet. And now B is really easy. Is C pretty easy? What's the answer for C? 20 newtons. Oops, I should write it all nicely. FF is 20 newtons. How about D? Is D easy? It was kind of funny. They said 0, 10, 20, 38. Why did they choose 38? Because it's not 39. That's exactly right. It's not quite to that threshold. So we were pulling here, and we were pulling here, and we were pulling there. We're so close, but we're not quite there yet, right? So close, but it's not going anywhere. So D, FF is going to be 38 newtons.
and then E is where it changes.
And E is where things change, right? because now I've applied 40 newtons of force, which means that I've overcome that threshold. Bless you. And that means that the box is going to start to move. Whee! There it goes. Now, how do I find the frictional force? The equation. Which equation? Is it this one?
No.
It's pretty darn similar though. Because what's the box doing now? It's going, right? And I'm going to change this one just a little tiny bit and put a little sub S here. And then I'm going to write the other one just to remind ourselves. So the force of friction, what was that one? Not static, it's kinetic. Kinetic means it's moving, right? Is mu K times Fn, and it's equal to. So this is for when it's moving. Moving, finally. Okay. So now you should be able to figure out in E, it said that the applied force, Fa, the applied force was what, 40? So we've overcome it. Mu sub K was 0.3.
Yeah.
Can you find FF?
Wait, are we using the normal force for this one?
You are. Yep. I just was reminding myself that it was over 40.
Oh.
Or it was over 38.9.24. So you got mu sub K is 0.3. You've got Fn is 98.1. Put those in there. What do you get for FF sub K? Would you say 29.43? You guys agree with him?
Oh, wait, I feel like I did. I would second that.
Second that, a third, a fourth, a fifth. I've got another question for you, but let me write that down first.
So would this be the answer?
Say what now?
This is the answer.
Those are the answers. Yep, all 5 answers.
Oh, I know, because I was just, like, because the first one, we didn't write that down. So we were just figuring it out what it was until it got moving.
Yes. Yes.
So this is-
How are we doing? Are you okay? What's up? Okay, thank you. I have another question before we do that, though. My last question for you. Here it comes. What is the mystery box's acceleration? It is a good question.
Oh, the slope intercept. Right?
You don't have to work. No, I would use this little. So I'm going to zoom that out just a little bit.
Wait, is it gonna be mu?
I'm going to let you guys talk with your table mates. If I were you, I'd look at this little bubble. Okay. I'm going to give you a minute to think about this. This is a new question. It's not written on there.
Wait, where's the acceleration? Where are you talking about it?
I want to know the acceleration at when the applied force is 40 newtons.
Okay.
Because otherwise it's 0, right? That's not very
That's
exciting.
what I was saying.
Yeah, yeah. 0 carbon and A, B, C, and D, like for, 4/5 of them. When FA equals 40 newtons. You got this, guys. You can do it. Do it, do it, do it.
I have to figure out what F that is.
Oh dear. How we doing over here?
Yeah, he said 11 minutes.
No.
Oh, 11.
10. Around 11.
Do you believe him? I mean, not very trustworthy.
Ooh, you're roasting. So much favorite.
Yeah, no? Maybe?
So it's not.
I don't know. I don't know the answer. I just made the question up.
Oh, boy.
I probably have made the question up before,
Yeah.
but I don't remember the answer. That'd be a lot to remember. I do not have a photographic memory. Unfortunately. You guys have answers
Yeah.
there? Yeah.
Possible.
Did you guys compare?
No.
Oh, you should compare with each other.
I did get that. That's what I did.
Did you guys get the same thing that they got?
What'd you get?
Probably not.
What'd you
Oh,
get?
well, that's not a very good attitude.
We got 1.057.
How can we all do the same?
Were you? No. We got.
I mean, I can explain.
No.
A little bit.
Do you want to start us walking through it?
Maybe.
Why don't you get us started, and then if you get stuck, then we'll call on somebody else.
But I just don't know if it's gonna be right. so-
That's okay. I believe in you, Janelle.
No. We got the same similar answer. Okay,
All right,
So
get me started.
we did 40 minus 29.43 to get the net force.
40 minus 29.3.
No, 43.
Oh, 4.3. Sorry, I'm just listening and not listening well. Okay, before I write anything else down, I want to know where those numbers came from. So this was the applied force,
Yes.
and this was the frictional force.
Yes.
And I'm just going to remind myself that that's really F net, because I want to make sure that everybody knows where this stuff is coming from, right? She's not just pulling numbers from who knows.
Right.
Okay. So and we know that's going to be our F net. So what did you get for that?
10.57.
10.57. So the net force acting on the box is 10.57 newtons. If the net force is not zero, what do you know about the acceleration? It's not zero. And you can find it. How do you find it?
So there's that equation, A equals F net divided by mass.
Yeah, that's a good equation.
We know the mass, which is 10 kilograms. So we do 10.57 divided by 10 to get the acceleration.
Fabulous. So, and I can even do that in my head, right? It's like 1.057. Yeah. Yeah?
That's right?
Yeah. I
I
mean,
know.
I don't have an answer written down, but that all seems like good physics. Yeah. I'm not going anywhere. Okay. Well done. We agree back there? Yeah? Cool. All right. I'm going to spend my last however many minutes I have.
Oh, 15 minutes.
I know. He told me a while ago. That's why I was wrapping it up. I'm not one of those people like, oh my gosh, it's going to stop now. No. Like, I just need to know what I need to be aware. Okay. I wanted to address questions about the lab. Okay? Because I don't know exactly where you guys are at. I do have for you some, okay, where did I put that? That's a good question. Hold on just a second. In a pile somewhere. Where would I put it? Ah, here they are. I did grade your last set of labs, your acceleration versus mass or versus force labs. Do you remember that we did? So I'm going to hand those. This is what I graded them on. So if you emailed me or shared the document with me, I have this for you, and I'll hand those out right now. Why don't you get your computers out and maybe keep a piece of paper out real quick, because we're going to talk for a couple minutes so that I can maybe answer a couple questions for you about those labs. Does that make sense? If I did not get your Newton's first and second law lab from you, like you just forgot to share it with me, didn't share it with me, didn't get it done, I am feeling so much in the holiday spirit, ladies and gentlemen. If I get it before Thursday of next week, I will take it for full credit.
Oh, see, I should have.
Holiday love right there. If you missed something on here and you want to make it up and you want to fix it, you just got to let me know that you fixed it.
Do
Okay.
it really in the holiday spirits. Do something about net neutrality.
You know what, sweetheart? If I could,
If you could, obviously you would. Real low.
I mean, obviously.
Maybe like the Trump, you know? Middle class working with very.
All right, get your stuff out, guys. We don't have a lot of time.
This is not AP Gov. We'll talk about that.
Can we still do quiz?
Okay, I need to figure out how.
Yeah, this week.
We're supposed to have to
Okay,
do
cool.
No, you.
All right.
Miss Carmen asked me to share it, so.
So do it. Yeah. Yeah. All right. Let's talk about that lab, you guys. Let's make sure that you understand because I would like that lab done by Friday so I can grade them this weekend. Okay? Yes? Yes. Yes, Miss Carmeling. All right. I don't know where you're at. I don't know what help you need. So ask questions to me, please.
I'm just confused about how was this graph from my book.
The one that I just gave you that was from the one where we had the carts with the pulleys. Okay, so we'll fix it. We'll get it figured out in just a sec. Magda, does that answer your question about that? Yeah.
What lab did you say?
Okay. There are two labs that you will turn into me via Google Sheets. Okay. The first one was the cart and pulley lab. That was the one where you graphed acceleration versus force or acceleration versus mass, depending on what your assignment was. Okay. If you did not turn that into me, that one was due a week ago. Okay. If you did not turn that into me, then please do so before the end of next week. Okay. And I will give you feedback. If you need help with it, let me know. The one I want to talk about right now is the friction and finding mu lab. Okay. So this is the one that we did at the beginning of this week, last week. I think it was last week, end of last week, right? Maybe like Friday, Monday or something like that. I don't remember now. This was the one where you had the block of wood and then you had the string that was attached to that, was there a string involved? Yeah. And then you had the force sensor. Right? Does it sound familiar to you?
Yeah.
And what did you measure? What data did you take, guys? Yeah, so you had the force of static friction and you had the force of kinetic friction. And what else did you write down? The mass. Okay. Is this sounding familiar to you? Okay. What did I want you to do with that information? I want you to find mu. How are you going to find mu? We talked about this a while ago, but let's do it. Okay, let's do it.
What were you supposed to use the y equals mx plus b?
Yes, you were. FF sub S, I'm going to write equals because I'm just going to look at that top point, right? That's what we're looking at. So that peak, so that's like the maximum is equal to mu times Fn, right? And then the other one was FF kinetic equals mu times Fn. Yes, is it okay? Okay. Ladies, I hope you're paying attention because I don't want to have to go through this a third time. Okay. This was the one where you found the average. Right? You looked over an average and you found that force over an average. Okay? Both of these formulas look like y equals mx plus b. Yes? They both look like y equals mx plus 0. Okay? So you should be able to graph your force of kinetic friction on the y-axis and your normal force on the x-axis. And it should give you a straight line whose slope represents what? Mu. Okay? So you should be able to graph the normal force on the x-axis, the force of friction on the y-axis. It should give you something like a straight line with a y-intercept of 0. And the slope of that line is mu. Okay? The one hang up here is that you didn't measure Fn, did you? No. But you did measure mass. Okay? We're going to put big air quotes around the mass of the block being 0 and just take that mass, unless you mass the block, which if you did, that's better. Okay? How are you going to find Fn?
What did you do?
That equation on board, the black one.
Yeah.
Yeah, because there's nothing else accelerating it up or down, right? So you've only got the Earth, gravity pulling down, and the normal force pushing up. You with me there? So if you take the mass times 9.81, that will give you the normal force. Okay. So let's write that down. So in order to do that, you're going to have to do a little bit of analysis. Mass times 9.81. That will give you approximately the normal force. Okay. So just like you did on the last lab with your sheets, you're going to have your raw data, your analyzed data or your adjusted data or whatever you want to call that, calculated data, and then you're going to graph. I tell you what, I don't want you to do the homework, the friction homework tonight. I want you to do this tonight. I want you to come in tomorrow with a lab, with a graph, and if it doesn't have the line, that's okay. But you need to come in and I will give you points for having done this. So please come in with a graph and all of your data points for the kinetic and the static friction. I posted the videos from the last time, so you can watch those and adjust. If you get really, really stuck, send me an email, okay? What's up?
What lab is it?
What are you asking, sweetheart?